Okay, so welcome to your first review video, which is actually just doing some examples to go along with the instruction that we had. So we're looking at deciding whether or not the sine law is the right thing to use to help us find missing components in a triangle. And not only that, we're also going to do a little bit of practice with sketching triangles in such a way that we can figure out whether or not we have the right stuff. Okay, so the first example, we don't really have any triangles to sketch here. We just have to decide whether or not the sine law would do what we need to help us figure out what's missing. So it says here, which triangle would we be able to use the sine law for if we wanted to find the missing angle theta? Okay, so for this first triangle, I have angle theta, and I have an opposite side, so that's good. But for both of the other sides that I have, I don't know the angle that's opposite them. So I don't have that known pair to fall back on, which means that side A is out. Or sorry, side A. Question A, option A, multiple choice, response A is out. So in the second one, again, I have my theta and its opposite side, which is good to start. I have a side down here, but I don't know the opposite angle. I have an angle over here, but I don't know the opposite side, so we're out of luck again. In part C, let's see here now. Let's add part C here now. We've got angle theta, and we know the opposite side. That's good. But across from this side 8, we don't know what the angle is, and across from the angle 52, we don't know what the side is. So again, we still don't have a known pair. Let's hope we've got it in part D. Part D, we've got an angle of 52 degrees and a side of 9 centimeters. So we do have a known pair. And then for angle theta, we know the side that's opposite that one, so we're going to be in business with part D there. Okay? So let's jump into another example, and we'll see how we would start that out and set it up. So in this case, it says, for a given triangle, the following information is known. Sketch a triangle and determine if the sine law could be used to find the length of angle C. All right, let's see what we've got here. I'm going to do my best to sketch an acute triangle. I'm not an artist by any stretch of the imagination, but that's going to be as close as I can make to a triangle just by sort of roughing it out. So my apologies for the messiness. All right, so we've got an angle A, which is 47 degrees. That's pretty small, so I'm going to poke that one over here and call that 47 degrees. And then angle B is 77, so this angle down here looks pretty big. I'll call that one 77 degrees. Okay, and then we know side A is 7.9 meters. And that, notice I put directly across from angle A. I don't know what side B is, and so the C's have to be in these two positions. So the question is, can I use the sine law to determine side C? Well, do I have a known pair, first of all? Yes, I do. I've got A's are a known pair. So if I want to figure out side C, I can start with A over sine A as my known pair. So that one I've got both parts of. And then I'd have to be able to find side C, so I'd need to know what angle C is. I don't know angle C in my diagram, but hope is not lost, because this is a triangle like all others, and we should remember that the sum of all the angles in a triangle has to add up to 180 degrees. So this is a good example for us to remember a bit of a triangle property here. So if I want to find out what angle C here is actually equal to, I know that I have to have 180 degrees in total, so angle C has to be 180 degrees, subtract the sum of the other two angles, 47 degrees, plus 77 degrees. Okay. So 47 and 77, I believe, is going to give us about 124. So this is 180 minus 124, which I think is about 56 degrees. Now, I've never been a whiz with arithmetic. I can do algebra pretty well, but arithmetic sometimes eludes me. But I think that's correct. So now that I know that sine C is actually going to be sine of 54 degrees, I'm going to be in business with this one. So I've got A over sine A, C over sine C, and I know everything but that guy. So yeah, I'm going to be able to attack this one. We're not going to get into the beeswax of how we solve the equation, or even, we probably won't even bother to fill it in here. So but that's okay. So in the next instructional video, we'll learn what we would have to do to solve that. Now that we know that the sine law would be okay to use, we'll actually learn how to solve it, okay? So quick rehash, remember all the stuff about labeling lowercase, uppercase opposites, and to determine whether or not the sine law can be used, we have to have, first of all, a known pair. Then the one thing that we're looking for, we have to have the part of it that's opposite, or we have to be able to find it quickly like we did in the last example. So that's it. That's whether we determine whether or not we can use that law.